There we go. And
I know.
all right, let's get started. So it's September. Welcome everyone. Welcome to the club meeting, and we normally do our homebrew contest this time of year. So we'll do that as our main topic for tonight. First, we've got a couple of items to get through, normal club business. Jojo, are you able to give our treasury and membership update?
Yes, and good evening. Let me share my screen. If I can do it.
Hang on, let me check. Okay, try now.
Okay, that's good. Thank you. Okay, I hope you can see my report. I can see it from my end.
Yes.
Good evening, everyone. This is Jojo, KN6HTD, the club's treasurer and membership chair. I wonder if we have new members here, but welcome if that's the case. Today is September 7, and we have started our renewal for the next year's membership dues. And we have some members trickling into renewing their membership fees. We have a new member, Brian, KN6QNQ. So just as a reminder, we have $20 for an individual, 10 for each additional family member, and 5 for students. For the membership stats, we have 148 total live members, additional 2 members from prior time. And then those who have paid for 2021, that's 137. And then we have 5 members who have paid their dues since September 1st. We have 62% of our membership who are ARRL members.
I don't remember.
Used to be paying a higher percentage.
I hear you, Sylvia.
Uh-oh.
Well, we encourage members to join ARRL, and that's what we are trying to do in every ham event. I bring my ARR banner and flyers. So thank you for those who supported our repeater fund, Marty and David. Thank you for your repeater donations. Our bank has 8,403.16. So that's inclusive of the 2,150.87 repeater fund, and our numbers match between the checkbook balance and the ledger. And thank you, Phil, for the email. I will work on that sometime soon.
Yeah, that's an annual thing.
Yes. So I have also sent the reimbursement for the last less than $10 to Carol for the DB19 VGA connector. I don't know if Carol is here, but the check already went out to the mail.
Thank you.
Okay. And for the last part, I just read that we have the new newsletter. This is an old link, so thank you, Ken, for the new newsletter. And I have some items here as a reminder for volunteer opportunities, education, and HamFest. There's the California International Marathon by the Sacramento Aries. The September 15 beginner's course for the CW Club. And Western Plaza ARC HamFest at Lincoln. Carol and I will be there. And then September 19, come support for San Francisco Marathon. I think I will be there too. And the last and most exciting part is the Pacificon on October 15, 17. I already reserved my hotel there. That is all I have to share for the membership and sector. Thank you.
Thanks, Jojo. Well done.
Thanks, Jojo. All right.
Let me remove this stop share. Okay.
All right. Thanks. Okay. Carol, can you give an update on our website and social media?
Sure. I'll go ahead and bring up the report. Let's see. Okay, you should be looking at this slideshow here. I'm Carol, KP4MD. I'm webmaster for River City Arcs. And this is just a report of the web resources for the club for August, it's the past month. Just a reminder, our web address is n6na.org. And this is the current look of the website, and this is going to change very soon. Right now, it's kind of frozen in this condition right now because Google Sites that hosts our website is doing a transition. So the only thing that's staying up to date on this right now is going to be the calendar. The rest of the content over there won't change until we do the transition to a different format that's going to be more mobile device friendly. And I'm working on that, and it should be hopefully within a week it should be live. But in the meantime, this website is still online. And I want to remind everyone about our nets. We have a page on the website also for our nets. The Wednesday nets tomorrow at 8 p.m. we'll have the 2-meter net 145.25, which is also accessible via Echolink and All-Star. And at 8:30 we have our 10-meter net 28.420 megahertz upper sideband. This is a frequency that everyone can use, even technicians and novices. So everyone is welcome to check in there. 9 p.m. we have the slow scan TV net on our 441.30 megahertz UHF repeater. We also stream that live on YouTube. We have people who check in. We have from Michigan and Louisiana. We regularly have people who check in on YouTube live and join the chat there, and they watch what we're doing. So we do have an audience out there, and anybody's welcome to join us and look at our interesting program where we exchange pictures and we try to guess what's in the picture, and it could be quite educational and entertaining. So also the DIY radio group has its own page there as well. And a lot of the members of that group are busy building their QRP digital watt meters. And thanks to KF6ABC, Bob Mix, and also Phil Sittner, KD6RM for spearheading the DIY radio group. It's an awesome service. We have a swap page, and this is a service for all of our members. Any equipment that you're interested in purchasing or that you have for sale, interested in listing there, just send us an email with pictures and description and maybe what you're interested in for this equipment, and we'll post it up there for up to 6 months. By the way, we will have a table. The club is going to have a table at the Lincoln Swap Meet. That's going to be on the 18th of this month up at McBean Park, as Jojo said. We will have a table there for the club. And if you have any items for sale that you wish to bring, what we normally have brought to the White Elephant sale, that would be a place that you can bring them, since we won't be able to do the White Elephant sale in October this year due to not having a venue for that. So we're using our table at the swap meet. And that starts at 7 a.m. by the way. It goes usually till about 11 a.m. and by that time everything's wrapping up. So I will be working there at the ARRL booth. So please stop by and say hi to Jojo and myself at the ARRL booth there at the Lincoln Hamfest. And that's at McBean Park. A report on website activity for August. We had a little drop in the page views. It went quite down quite a bit there, from 3,721 in July to 1,740 in August. And we attribute this probably to the relaxation of the lockdown, opening of more restaurants and venues, people doing stuff outdoors instead of on their computers so much, perhaps. But most of our views were 108 on August 18th. The most active page during August was our 10-meter page, which was interesting because we do have a page there, just kind of an introduction to 10-meter operation. And it seems that more and more people are getting interested in that with the upswing in the solar cycle and the improved propagation. A lot of skip coming in on 10 meters, and you can make some really nice long distance contacts with a very small antenna and not very much power. Homepage again was in second place with 308 views. The magnetic loop page was in third place. And then the all-star page and the swap page after that. As far as the sources for traffic to our website, 57% of our hits came referred through Google, and 31% were direct to our URL, which is n6na.org, and a few others from other sources as well. And again, most of our views came from the United States, primarily from California, then Florida and Virginia, and these other countries that you see in blue color there. All over the world, we do have visitors, international visitors to our website. As far as our social media goes, the YouTube channel is very live and doing well. We had 734 video views in the past month. We have a total of 332 subscribers, and we have 540 followers on our Facebook page and 143 followers on our Twitter page. And we still have a Discord server that's going well. Anybody interested in joining that to jump in and chat with other club members at any time, you're certainly welcome to contact us to get added to that Discord server. And I think that's about it. Yes, if you have any email, you want to contact anyone on the board or any of the officers of the club, you could send it to contact@n6na.org, and it will be routed to the individual and you will get an answer. So thank you very much, and we'll turn it back to Kevin.
Thanks, Carol.
You're welcome.
Okay, let me just go back to my screen share. All right. Before we get started with our main topic, the homebrew contest tonight, at the August board meeting, one of the items we discussed was an idea for how we could recognize Paul McIntyre for his service to the club. And for those of you who don't know, Paul was killed, and he was club president for 2019 and 2020, I think, and he'd been a long time club member. And so we were considering nominating Paul for a posthumous award. We want to use our Lyle Aufranc award that we use to recognize contributions to the club. And so we wanted to propose to the club if everyone would like to take a vote, and if we agree, then we'd like to recognize Paul for that award for this year. So we'd like to have a show of hands, or say like yay or nay in the chat window.
100% positive.
Okay, all right.
Aye. Is anyone opposed?
No.
Doesn't look like it. Okay, very good. All right, we'll award the award to Paul for his recognition to contributions to the club.
By acclamation.
Thank you. All right, thanks everybody. All right, so let's move on to our main topic for this month. So it's our homebrew contest. So for those of you who, if this is your first time that you've been a member of the club and you've participated in this before, so we have a number of criteria that we want to judge the entries on, and there'll be 5 points in each of these categories. Like, how well does the project meet its objectives, the quality of construction, originality, quality of presentation, can it be built with available parts, or creative repurposing of parts, and is it inspirational? So there'll be 35 points, maximum of 35 points awarded for each entry. We've only got two people who've volunteered to take part so far. So before we get started, we know we have Bob and Ken have something to present. strangely, like all of our judges, Phil, Carol, and myself, we've all got something to present as well. But because we're judges, obviously we're not eligible for a prize, but we've all got something to present too. But before we start, is there anyone else who has something that they've worked on the last year who would like to give an overview of their project? If you've got nothing prepared, it could just be like an informal like overview of what it is you've been working on in the last year, or if you have something prepared, then we'll give you a slot to present as well.
You know, something that could fit in there, Kevin, is if somebody's got an idea they want to start and they want a little feedback, a little hint on how to get going, that would be an appropriate thing to bring up tonight as well.
That'd be good too, yeah. Anybody have anything?
Yeah, Kevin, this is Dave. I've got one I can do a show on.
Okay, perfect.
I don't have much prepared on it, but it's
That's okay. All right. Might as well get on the list. But
I'm adding it on the list.
entries are pretty low, so there's a good chance of winning something. All right. Anyone else? So far we got Bob, Ken, and Dave. All right. Well, as we go, we'll probably have some time left over at the end. So if anyone else has got something like they want to jump in at the end, then we can slot you in. Bob, Ken, and Dave, you've probably got like 5 or 10 minutes or as much time as you need because entries are low. So all right. So do you want to get started with Bob? Do you want to go first?
Sure.
Okay.
Cannot start while the other participant is sharing. Okay. I clicked on share screen. It told me I couldn't do it.
Should be able to. It's enabled for you.
Yeah. Share screen. Oh, there we go. Okay. That's my screen.
There we go. Yep, we can see.
Okay. Back in December of QST, there was an article called the Tuna 10S, the bare bones synthesized QRTP transmitter. It was a transmitter that would put out a half a watt of CW. The transmitter is sitting on top of an old Collins vacuum tube receiver. The interesting thing about this is it's a mixture of modern and old-fashioned circuitry. I'm going to scroll down here. On the left is the transmitter. It's in a Russian cookie tin. The author built it in a Russian cookie tin, and it had 2 circuit boards. On the left-hand side was a digital board. On the right-hand side was an analog board. The digital board allowed you to set the frequency and display it on a digital display in front. So it was a mixture of 2 circuits. Now, when I looked at that, I said, there's a hell of a lot of wiring there. It looks a lot more complicated than it should be. But I thought it would be simple enough for some of our club members, especially members of the DIY radio sub club, to build it. And I talked to Phil, and Phil got interested. And like Phil always does, he goes in with both hands and feet. And so anyway, he looked it over. Next thing I know, he's built a printed circuit board, designed a printed circuit board. The printed circuit board combined those 2 boards into 1 board. Down at the bottom here is an Arduino Nano computer. To the left of that is a digital display. Above the Nano is a digital clock generator is one way of talking about it, or a synthesized signal generator. And over here on the left is a knob for an encoder. By turning the knob on the encoder, you can increase or decrease the frequency, and you can push the button, push the knob down in order to change the rate of change of the frequency. So this is a beautiful board that he put together, and I can't tell you how many members actually built it, but I think 10 people got the kits to put it together. But when I looked at that, I thought, well, there's some other things I could do. I'm an engineer, so I think, well, how could I improve it? And I'm not a CW operator, but I have a lot of fun with circuitry. And so I thought we could improve it by adding a keypad for entering the frequency. And I also wanted to raise the power up to 5 watts. And simplify the circuitry and lower the cost. So I went ahead to do that. It took me a bunch of time since I worked 40 hours a week. I came up with a circuit that costs about $21 plus shipping for the parts. The original transmitter was used by several hams to make contacts. And the author of the article had a contact with the Canary Islands, some 3,500 miles from his home in Maryland, which is pretty good on a half a watt. But most people want more than a half a watt. So anyway, so I put the circuit together, and I have a little demo here of what I designed and built. Here's the reincarnated Unit 10S. I'm going to turn it on now, and a display comes up. Well, it blanks out. Comes up for me to enter a frequency. Well, this is interesting. It doesn't seem to be running. Oh, here we go. I'm going to restart this. It had a bit of a problem, guys.
Okay, it's good.
Here's the reincarnated Unit 10S. I'm going to turn it on now. And a display comes up. It blanks out, waiting for me to enter a frequency. When I push the pound sign key, it registers on the display what frequency we're at. This is my Morse key. This is a repurposed telephone company key in their wiring closet. They used to have lots of these, and they would surplus them. Hiroki, the A860Y, he mounted it nicely, and he gave it to me. So wonderful gift. So I'll use that to key this little rig. So I'm going to push the key while looking at the display on the scope here. When I get it out, it is 27 volts at 7040. What you hear in the background is the KX2. So that's it. I guess that's the demo. That should be good enough. Anybody have any questions at this point?
What was the objective, Bob?
The objective was to have frequency entry by a keypad make it easier to enter any frequency in the 40 meter band. And it also will put out 5 watts. I don't have it set up for 5 watts for that demo. I have the bias cut way back because I don't want to damage the transistors or whatever while I'm experimenting. But anyway, it as shown, it puts out about 2 watts. And when I crank it up and add a third transistor, supposedly I can get to 5 watts. The guys who had a similar circuit got 5 watts out. So that was my goal. The circuitry is simpler. In order to program the microcontroller, I do it this way. If and when this image comes up, this is the way I program the microcontroller. I run 5 wires from an Arduino Uno, use the same old Arduino IDE, Integrated Development Environment. It only takes the 5 wires from the Uno. 2 wires are for power and ground up to the display connector. The other 3 connect into the connector where the keypad plugs in normally. And that supplies transmit, receive, and reset signals. So that's how you would update the microcontroller with new software. Anyway, that's that. The back of the board, the back of the board looks like this. It's wired on a strip board, it's called. There's like 45 strips of copper, vertical strips of copper, lots of holes in there. And I really like this way of doing homebrewing. It's quite easy to wire up a circuit, and it works well. So that's about all I had to show. I do have a wish list of things I would like to add to it. I'd like to have a 20 meter version to go with the receiver that Phil's going to show you. I'd also like to have a twin T side tone oscillator. I actually have that separately sitting here on a breadboard, and I'm going to add it to it. We also would be nice to have a transmit receive relay. And I'd also like to learn how to design a printed circuit board so I can be a big boy like Phil. And I think it'd be nice to have an optional encoder there for fine tuning. With the keypad, I can enter a frequency and then use the pound sign button, I can increase the frequency at some set amount each time I push the button. Anyway, I think that's everything I wanted to show.
Well done.
Any questions?
Is there any plan on getting this as a new club project?
Oh, you know, I'm not thinking about that, but you know, Phil and I are always coming up with new projects. Phil doesn't sleep at night, I don't think. I do, but anyway, we're both tossing ideas back and forth all the time. If there's anybody that would like to actually use this transmitter to make a contact, I would love it. I would love to loan it to you if you're a CW operator, because I'm not. I'm CW challenged. So, you know, I talk to my oscilloscope and I talk to my KX2 here, but I don't actually make contacts. I'm not capable of doing that with Morse code. So anyway, speak up if you're interested in doing that, or contact me by email, whatever.
All right, very good. Thanks, Bob.
That's it. That's all I have to say. I don't know how to get back. Oh yeah, up at the top here it says stop share. I'll do that.
All right. Any more questions for Bob?
Thank you, Kevin.
All right, very good. All right, should we move on to Ken? You want to go next?
All right, I can share the screen here. Yeah. All right. Yeah, view slideshow. All right, I have been watching a lot of YouTubes, and I've seen some battery boxes. Finally came up with one that most I didn't like. Found one I did and did some modifying and came up with this for my battery box. The box is a Harbor Freight ammo box. I have a 12 volt, 12 amp hour battery in it. The meter and switches came from Wired Electronics I got down at Pacific Con, and then USB and PowerPoint connectors I got are from PowerWorks I got at Harbor Freight. This is the inside of it. You can see the battery. I added a charge controller and an SAE bulkhead connector for solar input here. And there are 2 LEDs mounted on the end. There's a fuse block here, and then the switches are wired up there. The first switch turns on power to the whole box and turns on the power voltmeter here. The second switch turns on the LEDs, which are right here and do provide a pretty good amount of light at night. So if you wanted to, you could carry it around as a flashlight, but that's not what it really intended for. The third switch is the USB switch to turn on this. This is a PowerWorks, which is rated at 4 amps, where most that you find are 2 amp. Our one is 1 amp and one is 2 amp, but this is rated at 4 amp. Then the fourth switch turns on the power pole connector, and I have a LED light strip plugged in here to, show that it does come on. And that's the box that it came up with. I left off cigarette lighter because I very seldom use it. So that's my box.
Very nice.
Do you have any schematic or plan on this or list of parts? Because that sounds like something I would definitely be interested in.
I think I have a schematic drawn up, and I can show you the link to the video that I kind of followed for building it.
Okay, if you don't mind sending me an email on that, I would appreciate it. That's okay. I will. I'm on QR. My email is on QRZ.
Email me.
Okay.
I can't remember. Sorry, can't remember your name at the moment.
That's okay. The name is Neil. I don't remember forgetting anything, so it must be a case of age. I'll get in touch with you. Thank you.
Okay. Yeah.
Ken, did you fuse any of the circuits at all?
Yes, I did. I had fuse block there, and they all have fuses. In fact, I have the box right here. And you got fuse block right here.
Very good. Okay. Any questions for Ken? Okay, all right. Very good. Thanks, Ken. All right. Next up, we've got Dave.
All righty. I've got a battery box also.
I've had one of the Harbor Freight battery boxes that I have used for a while, and it always seems to run out of juice before I'm all done with it. So for this battery box that I built, I bought 2 of the whatever they are.
You're on mute, Dave.
You're muted, Dave.
All righty, it should be there now.
That's good. Yep.
I thought I'd unmuted it. My battery box is a little different than Ken's. I've got 2 of the 12 volt, 16 amp hour lithium batteries in it, giving me 32 amp hours, which should run it for quite a while. My scooter's got 2 40 amp hour batteries in it, and it runs all day, it seems like. So this should run for quite a while. I've added let's see. There's the top of the battery. I have switched to provide power to the whole box. I have a switch here that turns on lights inside the battery. So if I'm out in the dark, I can turn those on and see what's going on inside the battery. I have a charge port right there that I can hook the charger that comes with these or for these batteries. I can hook that in right there and charge the batteries. Let's see. Over here, I bought a 300 watt AC inverter. It's a sine wave inverter, so it'll handle any of the radios or TVs or any electronic gear that you want. It's also on a switch that I can run it. Right now, I kind of stole one of Ken's ideas and put some LED strip on the outside to give me a kind of an active flashlight. But when I use the inverter, I unplug that and plug the inverter in there and turn it on. I put 30 amp relays in the circuit on both of these switches to handle the current. I know the inverter is going to draw way more than what a switch would handle, and I don't want to burn the switch up, so I put the switch turns on a relay. I also added a little device that I found. It's a DC to DC converter that gives me 5 volts so I can charge any cell phone or anything that takes 5 volts. Each output is good for 3 amps. There's a picture. When you buy them, you get 4 of them. I gave one to Ken, and I put one in here, and I've still got 2 to use somewhere else. The battery box is one of the Harbor Freight jobs. here is the 300-watt inverter. It's got 2 outputs. It also has a couple USB outputs, but that's got to be plugged in for them to work. The others are hot all the time. I've got the 2 batteries down inside. They're kind of hard to see on that. There's positive on one, and there's the other. You can see the other battery there. I have a place to carry the inverter, and I also have a place to carry the charger for this. The outputs are all fused there, and I'm using 2 of them for an output, and I've got 2 spare fuses. I have a collection of USB cables so I can charge just about anything. I've got the micro USB. I have a new C USB connector in the package there that I carry. I've got an extra light that I've had for a long time that I'm using as I can use as an extension light. Here's the output port. I've got 2 power pole connections there that I can plug into. So, and then I have a box that's got 1 in, 5 out, I think it is. There's the wiring on the inside of the lid. Let's see here if I can stretch my cord out. There's one of the relays. And there's the other one that controls the power inverter. So I've got red lights there, or I've got a strip of white lights that light up on the and hold them over the box and see down what's going on down inside. That's about it. It's power box. It gives me power. I've only used it a time or 2, but it's seems to be doing what it was intended to do. Provides power. Anyhow, that's it. Questions?
Yeah, where did you get the relays?
Junk box out in the back, out of the garage.
Oh, you're lucky.
They're just regular 30 amp relays. You can buy on Amazon for, I don't know. I haven't bought one for so long, I forget. I don't know what they run in price wise, but
I think they're commonly called Bosch relays.
Yeah, they're the Bosch relays.
Dave, Chris Huber.
Yeah.
I have a quick question about your charging circuit for the lithium batteries. I got one of those little 16 amp hour gel or lithium batteries, and I was just using like a 13 volt power supply to keep it charged up, and then I let it sit, and they died real quickly. The shelf life I had a problem with. It might have just been a factory defect. I don't know if you have to have a special charger that pulses them properly, or.
Well, I got the one I bought is actually for the lithium batteries, and it's it puts out a little more than a conventional charger. It's, I think, 14.6 volts that it puts out, and that brings it up, and it's got a little LED built into it. You can't see it.
And what kind of shelf life do you have, or do you have to, put it back on the charger? Because I've read some places, I've had a drone where they said, oh, if you store them, you should have them at like 50% discharged. I didn't. I put them in storage at full charge and then killed them. And so
Well,
have you checked this over a period of time to see how they're holding up on their charge?
I charged these a couple of weeks before field day. I used it a little bit at field day and a little bit at the other one we do out at the ranch. And
so how many years or how long have you had them, and they seem to be holding up okay for you? It sounds like
June or July, I think it was. I bought them. But
so they're relatively new to you.
Yeah.
Okay.
I've had them less than 6 months, but I charged it up when I first put the whole thing together, and it's still holding 13.1 volts. So
I was wondering if anybody else has had a experience with long-term storage on lithium batteries. Because obviously, if you have the thing sitting there for 3 months and you're expecting to pull it and maybe have it worked right away, or throw it on a quick charge and just top it off. But I know like lead acid batteries, they discharge pretty fast in 2 or 3 months, where I was given the impression lithiums had a good long shelf life, but
well,
it depends on whether you have them fully charged or partially charged.
I left them fully charged after I built it, and what, 4 months maybe that I've had the thing finished. So and it's still holding that voltage, and I've used it a couple times just to play around with it. I found a little transistor radio that only runs on AC. So I plugged the inverter in and ran the radio, and on AM it had a whole bunch of static, but on FM it was nice and quiet. So,
well, with lithiums, you expect them to sort of stay at that constant voltage until about 90% discharge. So that can be misleading. It's like, how much of a charge do you really have left? So it's not like a lead acid or gel battery where it drops off and you go, oh, it's probably only got 50% charge left on it.
You mentioned something about having a drone, and I have a Mavic Mini. I read a lot and saw some videos about the Mavic Mini 2, which has a slightly different ion battery, and had that problem that if you store it with full charge, it'll go bad. You have to reduce it down to, I don't know, 40-50% for long-term storage. So I don't know if you've looked at some of those videos, but it looks like a variation of the standard lithium ion.
Yeah, that's a little tricky. How do you get your battery down 50% with a drone? You tether it down, run it for 5 minutes, and then go, oh, that's close.
They have the new charger that comes with it. It automatically decreases if you do that. A lot of articles about that. If you take a look at YouTube, I think you'll see some solutions.
Yeah, there's a tremendous amount of information about how to deal with lithium batteries. It's rather intense, I do believe.
Well, and you can get a little led by that too, so it's sort of like, oh, who do you believe? It seems like on the drones, everybody wants to discharge 50%. Others, I think I've read, said like 80%. And it's sort of like, okay. And then I know folks that have like motorhomes, they want to keep them up maxed out all the time. And it's sort of like, it's sort of a mixed bag on information.
More importantly, golf carts.
Well, they're charging and discharging those things all the time. Thank you, Dave.
All righty.
Thanks, Dave.
Any other questions? All right, Kevin, you got it.
All right. Thanks, Dave. All right. Do we have any other entries? Anyone else would like to do a walk-on presentation? Or as Phil suggested, like maybe talk about some idea for a project you've got coming up?
there's always somebody in this club willing to help. So if you ever come across an idea, let us know. It's fun stuff to do.
All right then. So that's our 3 official entries, Bob, Ken, and Dave. Phil, have you got access to the spreadsheet that Carol shared, so you can put in your scores on the spreadsheet?
I've wrote them down manually, and as soon as I finish my presentation, I'll go fill in the official score sheet.
Okay, cool. That works. All right. So for our unofficial entries, do you want to go next on yours?
Sure. I'll hop on share screen. Hot dog, basic, share. And let me kill this. Oops. I'm trying to get rid of this thing. Hide video panel. There you go. All right. So I call this the spirit of homebrew. If it seems possible, then go for it. And this is in recognition of a member of our DIY radio group. This fellow, this is Bob Mix's close friend, Hiroki Kato, I believe it's pronounced. He was on the front cover of the August 2021 QST with his coffee can 15-meter vertical antenna, but he's much more than a coffee can antenna kind of guy. So he got to thinking about this topic of, in an emergency situation where you can't get your hands on batteries, what do you do? And so he got to researching various battery options, and he came up with two prospects. One was potatoes, believe it or not, and the other was lemons. What you're looking at on this screen is his interpretation of how to build a lemon battery. Those plates that you see, one is zinc, the other's copper. And you can see that this combination is currently producing 6 volts on his voltmeter. So he's got a couple of things going on here. He knows that this is limited in current capacity. And the normal arrangement is to provide 3 volts. He does a series parallel arrangement to get 3 volts. And he wants to limit the current draw to around 10 milliamp to enhance battery life. So his first rig was this thing. It's a hearing aid box, he told me. And inside of that thing, you probably can't make it out, but in the lower right-hand corner is a little micro switch. That's the key. And the oscillator in there is a little CMOS computer chip oscillator block that's operating at 14.31818. That chip's designed to operate on a 3.3 volt supply. And he was pretty pleased with that little transmitter. People could hear him, but he didn't know how much power it was producing. His watt meter at the time wouldn't measure anything that low. So lo and behold, he built the River City Amateur Radio Club QRP digital watt meter. And you can see right there, he's producing 0.3 of 1 milliwatt. That's a lot of pizzazz, isn't it? So anyway, he thought that was pretty cool. And then he decided he needed a receiver to go with it. So he found a circuit in one of the publications, 20-meter regen receiver. He built that inside of some other kind of container.
It's a
beverage
coffee can.
container, possibly. Anybody know what that is?
Coffee filters, it says.
Oh, there you go. Coffee filter container.
Coffee can.
Goes well with lemons. In any event, he built that thing and he said it performed pretty awful for him, hard to tune and floated around and things weren't working so well. So I said, well, let me see if we can come up with something to help you. And this old buddy of mine, gentleman by the name of Ronald Kwan, who's published several books. He's got over 70 domestic patents and over 700 patents internationally. He happens to be quite an authority on low power circuits. And in this book, he features one radio, AM radio, that will run for 5 years on one C cell. There's no on-off switch, it just runs. So Ron's quite an authority on low power radios. And he came up with a design that he thought would satisfy Hiroki's needs. So I put together a board for him. This is a 7 transistor design. The crystal plugs in right here. And it's a VXO. With VXOs, you can vary the frequency of that crystal about 2 kilohertz. This is a little peaking inductor for the oscillator. And then you've got one little trimmer here that peaks the input filter. And then this other one peaks the network that drives the mixer. So pretty straightforward. As I said, 7 transistors, your earphones plug in here. And this is designed to work with a crystal earphone. If anybody remembers your early crystal radio days, that's what we used to use because they're very high impedance, very small load, and they work pretty well. So Hiroki builds a new transmitter, a 2 transistor affair, again using the North. What are we? We're the River City Amateur Radio Club.
DIY radio
meter. And this thing's now producing 1.6 milliwatts and feeding his dummy load. He's got an SWR of 1.2 to 1. So that satisfies the need for a little more power. So here's the final power consumption. Remember the objective, keep it under 10 milliamps and operate at 3 volts. In the receive mode, he's using a little different earphone than what I used. I ended up with 1.4 milliamp current draw. He's now using 9.2 milliamps to produce his 1.6 milliwatt output in the transmit mode. What that translates into is about, what did I have listed here? 6% efficiency in the transmitter. You get out 1.6 milliamps from an input of 27.6 milliwatts of DC power. So those of you who are looking at this and laughing, Bob mentioned Canary Islands on half a watt. This gentleman, who is KI6DQ in 1990, this is an article out of 73 magazine, November 1990. This guy managed to work all continents with 2 milliwatts. And that apparently translated into, and it's listed right in here somewhere, 333,333 miles per watt. So there's something to entice you to try something different. That pretty much is a story on Hiroki. I should also share with you that Hiroki is also quite a World War II clandestine radio fanatic. He's got every kind of trench radio you ever heard of, spy radio. And he often does presentations at Pacificon. He's volunteered to a dress hike group. I believe he gave me a tentative date of February of next year. He's a fascinating guy. He grew up in Hiroshima, Japan. He was 4 years old, living 20 miles away from the city when that bomb dropped. And he actually went to school in Hiroshima and eventually immigrated to the US. I think he taught at 3 different universities. Isn't that right, Bob?
4, yeah.
4
Harvard,
universities.
yeah.
Incredible guy, nice guy. But again, you know, the spirit of ham radio and especially DIY radio, the homebrew thing, if you come up with an idea or an issue and you want to make it work, you know, you put a couple of toes in first, and then you get the whole foot in, and then you immerse the entire body, which is what Hiroki did. You know, he looked at the battery opportunities, how to build a battery, how to build a transmitter that would work with the batteries, how to build a receiver to work with the batteries. And he's enjoyed several QSOs with this little rig he put together. And as I mentioned earlier, there are people willing to help. So if you got an idea, don't be afraid. Jump in with 2 toes, then the foot, and then continue the process. That is all I have, gentlemen and ladies.
Great story.
Very inspirational. Thanks, Phil. Any questions for Phil?
And I see Hiroki's real quiet. He's part of the audience here. Thank you for being here with us.
Oh, is he in here?
Yes, he is.
I hope I didn't offend him.
Do you want to say hi, Hiroki? If your mic's working, you want to unmute? Okay, maybe.
Hi, I don't know whether you can hear me.
We can, yep.
Yeah, I joined late, so I came in the middle. So I missed half of the presentation, but if you have any questions about what I did, I'd be happy to. That Phil represented me very, very well. So I don't have anything much to add. So it's been fun to play with the potatoes and lemons, and actually I tried some other fruits too. But one thing I'd like to mention is this: in experimenting with all kinds of fruit and vegetables as battery, I learned that if you cook any of these vegetable or fruit, the output increases dramatically. So a single potato uncooked may produce the about 0.6, 0.7 volt, but only about 1/10 of a milliamp output. But if you cook it, it goes over 1 milliwatt. So you can easily imagine if you put 5 or 6 together in parallel and in series, you can create 10 milliamp. And so that's what Phil was talking about. What can you do with the 10 milliwatt, both for receiving and transmitting? And well, surprisingly, with 10 milliwatt, with the output of 1 milliwatt or 1.6 milliwatt transmitter, you can have a very secure CW communication up to about 5 miles. And of course, depending on the condition and depending on what kind of antenna you use, you can, under certain circumstances, you can reach the world, as Phil mentioned from the 73 magazine article. And of course, we are not exactly in the optimal sunspots cycle, but it's coming. And the records registered in that 73 article were made in 1990, which was one of the higher the sunspot cycle point. So with the coming of the peak of the cycle 25, I wouldn't be surprised that we could be having a good DX with the very, very small power output. So if you have any questions, I'd be happy to answer.
I have a question. I was looking on the web and there's pineapples, oranges, peaches, and tomatoes are the highest acid fruits. Did you use any of those?
I have tried these. The problem with the fruit battery is this: how do you keep the electrodes standing up stably? If you make juice, obviously you have to kind of rig the anode and cathode, and that's kind of a pain when you have to have many cells. So the solution I came up with a potato, you make a mashed potato, and with the lemon, instead of using a lemon juice, you use use a blender and so pulverize the lemon with skin and everything, and then you have a kind of a quite viscous material. Then it's easy to have the electrodes standing up.
Okay, I was thinking, so tomato juice might work.
Yes, tomato juice will definitely work.
Have you tried a Bloody Mary?
Not yet.
That's exactly what I was thinking.
Well, how about pure vodka? Maybe that may be worth trying. But
you could do it, but you got to learn to speak Russian.
Yes, well, but then you are talking about the very expensive battery. Of all the fruits and fruits and vegetables, potato, especially the Russell potato, is the cheapest of all fruits and potatoes I have come across. The Russell potato sells about $1 a pound in my neighborhood grocery. And lemons are slightly more expensive. So if you are going to talk about some of the practical application, let's imagine a poor African village where there's no electricity, and the inter-village communication can easily be obtained with a set of the transceivers we're talking about. But the cost of the fruit or the vegetables becomes an issue. So you want to keep it down. By the way, mashed potatoes can last up to a month without losing the output. The lemon can last only up to a week. And pretty soon, lemon will, within a few days, start getting moldy, depending on your environment. And so from that viewpoint, the potatoes, even though the native voltage you can get from potato is lower than the lemon. Lemon can get up to 1 volt as opposed to potatoes anywhere between 0.6 to 0.8 volt. But potatoes are longer lasting, cheaper, and easy to obtain.
So it sounds like Professor Proton on the Big Bang Theory was correct.
What did he have to say?
Well, it was a character on a TV series that he used to watch TV, and there was a little professor teaching kids, and the main thing he always mentioned is how can he make electricity out of a potato. So
Did you try doing any blends of like potatoes and lemons? And does that make any difference?
Pardon me?
Did you try doing any blends of like potatoes and lemons and like mixed together? Does that make any difference?
I was going to do that, but I haven't.
Okay.
I have a question, Hiroki. Does it matter how far apart the
Sorry, I think by
I think Bob's got freeze face.
Yeah, he's frozen.
yeah. The question is what? How far does it matter if the distance
Separate the
between electrodes? Yes, the voltage doesn't change, and but interesting thing, when I was using just the cooked potatoes as opposed to later mashed potatoes, when you squeeze the potato, output really increases. You just press the zinc and the copper plates.
That's called electrostriction.
Okay.
There's a term for it.
Is that right?
Yeah.
So maybe there's a way to package the mashed potatoes, some the pressurized packaging.
Maybe you could get your wife to dial in the thumb screws as you're running the key.
I have been banned from the kitchen because I made a lot of mess. So it won't happen anytime soon, unless she goes on a vacation for a week.
Well, it looks like Idaho has plenty of emergency power with all their potatoes up there.
Yeah, well, I was, Carol, I was thinking, watching what's happening in the Hurricane Ida. There's what's that, the name of the island in Louisiana, where some residents, about 400 residents, were stranded. There was no way for them to communicate. Naturally, a cell phone is gone, and nobody has batteries. Well, that's when the probably potato, if somebody has a potato in the kitchen, that may be the time when you have at least some level of communication. All you need is just to communicate with 3-4 miles. So.
Very interesting. All right, okay. All right, can we move on? Next topic? Or any questions for Hiroki before we move on? All right, Carol, do you want to go next? And then I'll follow after you.
Oh, sure. Yeah, I'll go ahead and share my screen. And let's see. Okay, thank you very much. I'm going to talk a little bit about my QRP antenna tuner. This idea came about. This is, I have to say, it's not very original, but there is some originality and some thought that has gone into this. This is, again, it's another boost for the DIY radio group. Our project that we did prior to the QRP power meter was a transmitter, which was the Tuna 10S. And I built one of those, and there's a little picture of mine in a little plastic box I got at Tap Plastics. And the total cost for the parts for this little transmitter was about $25. And it puts out, about half a watt. And one thing it doesn't have a built-in tuner. And in order to maximize the efficiency of this transmitter, you should have an antenna that matches the impedance, matches the output impedance of this transmitter. So I wanted to have some kind of a matching unit to be able to do that. And hopefully it was not going to cost any more than the Tuna 10S itself. So that was a pretty tall order. So I did a Google search and for a QRP tuner, and it came up with these automatic tuners. There was a Chinese one called the ATU 100, which is $114. The Elecraft T1 kit was almost $200. The LDG has a really nice automatic QRP tuner, the Z100, and that's $149. That's way multiple times the cost of the Tuna 10S. So then I looked at the manual tuners, and this is not an exhaustive list of them, but the 4-state QRP tuner kit was $45. The MFJ 9201 QRP tuner is assembled, but it was $64. And QRP Guys had this multi-Z kit, which was $40. And then there's another one I found on eBay and on Amazon, which was the Z-Roan or the Manual Days kit. And that was only $15. And I said, wow, that's awesome. I'm going to try and go with that one maybe. So just a little comparison of some of these different kits that the kits that I saw. This is the 4-state QRP tuner. And the specification says it'll take up to 10 watts. It'll run 80 through 10 meters. It has these two little LED lights. One that lights for forward power, and the other one it dims when you've got a low SWR. So that's pretty neat. And the design is and the documentation is very clear. It's by Dave Kripe, NM0S, who is a great kit designer who has done a lot of presentations in conventions and on the QSO Today expos. He's wonderful guy, and this is a very well-tested kit, and it has very good reviews. This is the MFJ 9201. It's a little pricey. It's 100-watt intermittent, so it's not really a QRP only, but it does also claim to have 80 through 10 meters. And nope, does not have an LED SWR indicator. That you have to cross that out. That's a mistake. But the manual is online if you want to look it up. And then let's see, QRP Guys has a multi-tuner kit, and this one is $40. Did I do that one already? No, I didn't do that one. That one's 5 watts continuous, 10 watts intermittent, 40 through 10 meters. It also has an LED SWR indicator and has a nice assembly manual online. And then this is the one that I decided to go with. Actually, I had it on sale through Amazon. It was $13. And since I have an Amazon Prime account, I was able to order it and get it the next day delivered, which was another bonus. They claim 5 watts continuous power, 15 watts intermittent. It'll actually cover 1 to 30 megahertz. So theoretically, it'll also cover 160 meters as well as 10 meters. And it does have an LED SWR indicator. But the cons against this was there were very discouraging online reviews. VK3YE, Peter Parker put one together and he absolutely hated it. Said it didn't work the way it was supposed to. And the manual is in Chinglish, and it's got a lot of errors in the translation. Many people said they would try to build a thing and it wouldn't work. So I decided I'm going to go ahead with this anyway, because you can't lose very much, for that price. Maybe you don't follow the instructions, but figure out why the thing doesn't work and get the thing to work. So just use a little bit of noodle power there. And these are the kit parts that it comes with. You have this enclosures, plastic enclosures, completely undrilled. So you have to drill the holes to mount all the parts. And it comes with the BNC connectors, a couple of knobs for these polyvaricon capacitors, LEDs, some capacitors and resistors, a little PC board, which is used for the SWR sensor circuit. And it's got a 12-position rotary switch, which is for the different inductance values. And there's a toroid ring, which is used for the main inductor in the matching network. And there's a small little toroid here, which is used for a pickup transformer used to feed the SWR sensing circuit. You got a little toggle switch and then some enamel wire and regular hookup wire. And then these things are labels. What you do is you put the label on the box And then that's a guide for you to drill through. And the label also serves to label the different controls that you mount in there. So problem is that these labels, you have a few words here in English, but most of the other labels are in Chinese. And I think this contributed to the problem of the reviews where people had no idea what they were switching one way or the other or what goes in or out because that was all in Chinese. Well, let's go about the circuit description. It's a standard T network tuning unit. It's got two variable capacitors and one variable, it's a switchable inductor. There's a resistive Wheatstone bridge on the input. And the way that works, when the antenna impedance is 50 ohms, the bridge output is 0. It's balanced, so there's no voltage appearing across the primary of this toroid transformer. And the other side of the transformer goes to a little rectifier circuit that feeds the LED light. So when you have a perfect match, there's no voltage, therefore the light just goes out. And then when your SWR is high, which is when the impedance is far away from 50 ohms, you'll get a voltage there, which will light the LED. So you tune the thing for minimum light on the bulb. When you do put the circuit in, it causes 6 dB attenuation, and you only switch it in to adjust for the minimal SWR. Then you're supposed to switch it out. And that's one of the other problems on the video. Some of the video reviews of this is people had no idea that you had to switch the sensor circuit out, and they said, oh, this thing causes a tremendous drop in your power output. Well, it does that if you leave the sensor in the circuit. Here's a schematic diagram. Again, this is the input here. Here's your double pole, double throw switch. When you're feeding it straight through without the sensor, it just goes to the T network. And this is the Wheatstone bridge here with the little transformer that steps up the voltage that it picks up here on the Wheatstone bridge, and then it's rectified through this diode. And we've got a little current resisting limiting resistor to the light emitting diode. Now, one of the problems here with the original schematic is this is the way they explain how to wire up this switch to the coil. And what they did was for the minimum resistance, which is where I'm sorry, I have to go back here, where this wiper contact is all the way at minimum resistance. They actually had it at a point where there was 10 turns on the coil. And then down at the point here where it was supposed to be a maximum inductance, you had these like 1 turn, 2 turns, 3 turns between the contacts. The error with that is that you need the fine tuning on the inductor where you are at minimum inductance. So this was inverted. And if people wired it up this way, they would have very much difficulty getting the thing to tune properly at the higher frequencies because they would have a fine adjustment of the inductance. So we had to flip that around in order to get the thing to work. And this is just a curiosity. This is the 4-state QRP tuner. It's almost identical schematic diagram. There's the T network right there, and then this is the Wheatstone bridge. So you see, it's pretty much a it's not a very original circuit. It's one that's been very much copied many times. So I had to do a wiring correction on this inductor. And again, I did the turns between the switch contacts, the smaller number up here, where the inductance is the smallest values. And this did work. So I was able to get this thing to work. Now, polyvaricon, people may have not heard of this word before. That's a polyethylene film dielectric variable condenser. That's where that word comes from, polyvaricon. These are little variable capacitors that are made of plastic. They were very common in transistor radios that used these devices and coils. Nowadays, these radios have everything solid state, varactor tune and stuff. So you very rarely see these very much anymore, but they're still out there and they're a dime a dozen. The Chinese make an awful lot of them. So since they're so cheap, they were using these in this project. They don't have a very high voltage they can't withstand very high voltage because they have this little thin sheet of polyethylene film between the plates. And those would arc over very quickly if you put any high voltages on them. But for a QRP application, there's no problem with them. There are two sections. One of them is for the oscillator and one is for the antenna input of a transistor radio. But if you parallel them, you get a total of about 200 picofarads on each of these, which works perfectly in this circuit. The other thing was these knobs that they provided. Now these polyvaricons, as you can see, they have a really peculiar way of having to attach a knob. It's this little tap hole here in the center, and then this little nubbin of a type of a shaft. And you can't really stick a regular knob on there. It has nothing to grab onto. So what they did was they rigged something up where you have this screw that goes through this knob that has a hole down the center, and then poking the bottom of the screw out through here, you would screw that into the capacitor and hopefully have enough friction so you'd be able to turn it both ways, left and right. Well, this is the top here is the hardware they gave you. And first of all, this nut did not even mate correctly with this screw. So this was not going to work. When I did get the correct, let me back up on there. When I did get the correct nut, which was an M2.5 that I was able to find at Ace Hardware, you could turn it to the right and it would turn the capacitor to the right. But if you turn it to the left, it would just completely unscrew out. There was nothing grabbing onto that little shaft to turn it backwards. So I fixed that by adding a little tooth lock washer here. And you tighten that on there and it digs in enough into that little brass shaft there that gently you can rotate it either way. So this worked very well. There are some other fixes where you could do a 3D printed shaft that fits over that, but I don't have a 3D printer. The SWR sensor board, this is the circuitry for the SWR sensor. There was an error in the printing on here too. They had this is the toroid transformer was supposed to go in here. It was supposed to be 2 turns on this side, the input, 5 turns on the output because it's stepping up the voltage. They had this labeled in reverse. And if you did it this way, you would have too low of a voltage to light up the LED and you would think the thing didn't work at all. So I had to make that correction. And these are the Chinese labels. Actually, where here it says like SWR indicator and bright, high SWR, dim, low SWR. Those English words were not there at all. All there was a Chinese labeling. And this was the switch on the top, SWR position and normal position for the toggle switch. Again, the English letters were not there. It was just Chinese. I had no idea what this was all supposed to mean. I guess I could figure it out by looking at the circuit. But if somebody built it and tried to figure out what was going on, they would completely be at a loss. So I used my Google Translate app on my smartphone, which you can flip it over to use the camera, point it at that Chinese printing, and it actually shows you right on your screen what it's saying, so you can translate it into English. So I added that onto the label, so able to use this thing properly. If you didn't do that, you might even say the thing didn't work because you didn't know how to use it. And then here's another thing. The sides are the input and the output. And one is for the radio, one's for the antenna. And if you didn't have those English words there, you could turn the thing, you can hook the thing up backwards. And then the SWR circuit would be in reverse and it wouldn't work at all. So you would think the thing wasn't working if you had the thing connected the wrong way. So we did put together the project and I drilled all the holes, mounted all the parts. And this is to show you the 2 polyvaricons. In the center is the tapped inductor. I had to wind a certain number of turns of the magnet wire around the toroid and then make taps that I have to scrape the enamel wire off and solder them onto each of the contacts of that 12 position rotary switch, which is behind that toroid. And that was one of the major projects putting this thing together. You'll notice that the BNC connectors on the left and the right, I took a piece of number 14 solid, let me back up here, solid wire, copper wire, and I just ran it along the side here, connecting the shield or the shell of both of those BNC connectors together to give a low impedance path. And I also use this as the ground connection for the network inductor. So, and also for the wiper connector on the rotary switch. So this was a way to get a good low impedance connection there. And these are all the other wires. It's a very simple circuit. And this is the front again of the unit. So I went ahead, I put the thing together. I wanted to do a little test of efficiency to see if this thing was going to be wasting a lot of my milliwatt power or if it worked at all. So I hooked it up to my Nano VNA, and a lot of us do have these. And if you don't have one, I do highly recommend you get one. There's just so many good things you can do with the Nano VNA besides testing antennas. And one of the things you can do is tune a filter or a matching network like this. So I take the output of channel 0 of the Nano VNA and I put that to the input of the tuner, and then the output I feed it to channel 1 on the Nano VNA. And all you have to do is then adjust the band switch and then the 2 capacitors for a minimum SWR on the frequency that you're testing it at. And then it will also show you how much of your power is getting through from one side to the other. So it's telling you what the loss is in dB, and it's really cool. This is one test that I did. I'm using, of course, the Nano VNA Saver, which is a PC app that connects to your Nano VNA so you can get nice big pictures on your computer screen. And this was a test at 10.2 megahertz, which is around the 30 meter band. And if you can see here, the SWR there was 1.003. And the way you know what the loss is, you go to this number S21 gain, and it's minus 0.934 dB. So it's almost 1 dB loss, which is not a big deal. So it's halfway decent. I went ahead and I did this testing on all these different bands, 80, 40, 30, 20, 15, and 10 meters, and comparing the all the VSWRs. The SWRs were pretty low, like right by 1.0, pretty close. The gain here, well, on 80 meters where I had the most loss, it was minus 1.7 dB, almost 2 dB. So I think the problem there was the inductor is a pretty low Q at that frequency. So it's a little bit lossy there. But on the other frequencies, like here, 30 meters, 20 meters, it's 0.5 dB, 50 meters, 0.3 dB, and 10 meters is 0.3 dB. And I think this is going to be very close to what some of the other antenna tuners you see out there on the market. They're always going to have some sort of insertion loss. So I'm going to just say the conclusion that I found from this experiment was, despite misleading instructions, a lot of discouraging reviews on the internet, and really bad translated Chinglish instructions, you still can get this thing to work. And it's a fun little box. Here it is. So, and for $13, I couldn't go wrong. Got a little thing that mates up with the Tuna 10S. And that's the end of my presentation. Thank you.
Thanks, Carol. Any questions for Carol? All right. So while I'm presenting my section, Phil, do you want to email your scores across to Carol or enter them?
I already did.
Yeah.
Do you have them, Carol? Have you seen my email?
Oh, did you send them already?
Oh, I sent them several minutes ago.
Oh, okay.
I had a
Back
question
just as
for
she was
Carol.
starting her presentation.
Can you folks hear my question for Carol?
Yeah, go ahead.
Yes.
Yeah, it's Wilson, N6EMF. Nice presentations out there. And the question I had for Carol was, when she was finding those problems with the coil orientation reversals? Did you do that by visual inspection, or was it after you put it together and you had to troubleshoot it?
No, I was very suspicious of all of the instructions to begin with. So I analyzed this circuit just looking at the schematic and looking at the instructions, and I knew it wasn't going to work. So I did that even before I put it together.
Oh, that's very good. So yeah, thank you for sharing that. I was wondering how you knew. I just couldn't imagine you going ahead and finding all those bugs and then having to desolder things and turn things around. So that was very clever approach. Thank you.
You're welcome.
Very great when you have the tools and you know how to use it and the skills to do it. So good job.
All right. Carol, did you get Phil's email with the scores?
Yeah, I'm looking for it right now, but
Okay.
you can go ahead first, Kevin.
Okay. All right. Sounds good. All right. So let me share my screen. All right. So what I've got is I'm building on a project that I presented. I think it was for our 2017 Homebrew contest. And this is a picture of what I built for that 2017 entry. There's my to-go packet kit. So I've got a Raspberry Pi and a 7-inch screen, a little mini keyboard, all battery powered with a handy talkie in there, like for a mobile packet kit. And what I was thinking was, how could I expand this, or how could I add to it to add some more interactive things to this packet station? So I was thinking along the lines of like BBSs that people used to dial into and used to have like interactive games and things like that. And it turns out a bunch of people had set up some stuff like this before. So then I was thinking, okay, well, if people have set up a packet BBS and they've had like some text adventure games on there, people have done that, then what else could you add? So I was spending some time getting some things set up. So I've got a video that I can share of some of the things that I got set up. So let me play this video for you and let me know if the sound comes through.
Hey everyone, this is Kevin, KK6DCT. I'd like to give you a demo of a packet radio project that I've been working on. I thought it'd be interesting to set up something interactive like a BBS. And what initially got me thinking of this was I thought, given the text-based nature of packet radio, I thought it'd be interesting to set up something like a text adventure game, like Colossal Cave or Zork or something like that. But it's not surprising that there's been a few people who have already set up things like that, and there's some articles on the web you can walk through that describe how to set those up. But I thought, well, if that's possible, then what other things could you set up in a similar kind of way? So I was thinking of setting up some interactive things that you could connect into over packet, and I'm going to give you a demo of some of the things I got set up. So first off, what we're looking at here is this is all running on a Raspberry Pi 3, and it's connected to a Hooke 2-meter handy talkie, and it's connected to the Pi with a signal link. So we're just running low power. The Hooke is connected to a Edfong antenna, which is just hanging in my window there. And in a couple of minutes, when I've done the initial setup, I'll show you connecting in with another 2-meter station, and we'll test out the BBS. So to start off with, this is running with Direwolf. So I'm just going to start this up. This is the software-based TNC. So we'll get this running, and then couple of steps just to set things up. So I need to start up the X25 stack, and then I've also got a few things for the BBS to start up. So if I look in this file here, we'll start up NetROM and attach it to X25. So we'll start this running. Okay, and then that's ready to go. So I'll leave this window here running so we can see what's going on inside Direwolf here, but at this point we should be able to call out as well, so I can give you a quick demo of that. So if we do an AX call to 37, and that should dial out. it goes, and it connects, and we can look at the nodes that are over there. And there we go, so that's all connected and good. Alright, so we'll just disconnect from that for a minute. So that side's all up and running and ready to go. So we'll just say bye. And that's good. And if we go back over to Direwolf, we can see the packets are going backwards and forwards there as we were talking to that node. Alright, so now I'm going to switch gears and I'll show you dialing in from another station, and we'll check out the features that are on the BBS that I've set up here. Okay, so what we're looking at now is a terminal screen which is connected to an AEA PK232 TNC. Just turn down the volume a bit there, and that's connected to ICOM 2-meter radio, and we're on 144.37 right now. And so what I'm going to show is connecting through from this second 2-meter station. We're going to connect into the BBS that's running on the Raspberry Pi and using the other 2-meter handy talkie. So on the screen where you can see Direwolf, you can see the messages going by. That's the packets that station's picking up. So you better see the interaction there. And then over on the Amber VT terminal here, we'll call into the BBS and connect and see what we've got set up. So first of all, I'm going to connect to my station, KK6 DCT6, and we'll connect. I'll turn the volume up so we can hear the packets going backwards and forwards. There we go. Alright, so we're connected. So what I've got set up here in this first menu is a number of things that I set up. There's some weather lookups, there's some news, and like I said before, I was interested in getting some interactive games set up as well. So there's Colossal Cave, there's Orc. Just take a look through some of these things here. So first one was I wanted to do like an interactive weather lookup. So you want to see the weather right now. There we go, and it comes back with the weather, or if you want to do 5-day forecast, that is there too. There we go, and then let's do the 5-day forecast for Sacramento. So that is on W4. So it should prompt me for a city name. Here we go. So we could say Sacramento. And then off it goes, and it's calling app on the Raspberry Pi. Does a look up for Sacramento. Alright, so that's pretty cool. Let's just go back, see what else was in the menu. So we also had some news headlines as well. So these are slightly more interesting. So what these are doing is connecting to the Raspberry Pi, and then I've got a Lambda on AWS Cloud which is running, which is going off, pulling back the RSS news feeds from a number of different websites, and then doing some parsing on it and stripping out any characters that won't display on the terminal, and just showing the headlines. So if we select N1 from the menu here, go off, here we go, I'm going to get the ARRL headlines, and back comes the news. And then the other ones I had set up, amateur radio newsline as well, that was on N2. So same thing, it goes off, connects to the node there, and calls the app that's running in the cloud, gets the RSS newsfeed, strips off some characters and stuff, and then brings back just the headlines. And what was the other one? I think there was one more. We also have the Southgate amateur radio news, and off it goes, and back comes the news. Alright, so I hope you enjoyed my demo. It was some fun setting this up, and I've got a few other ideas for some other interesting things I could get set up as well. So I hope you enjoyed the demo. Thanks.
Alright, that was my demo.
Well done, Kevin.
Any questions?
Well done.
So Kevin, what's the baud rate for your BBS?
It's 1200.
Okay, it looked slow, but
Rip roaring fast.
it's been a while since I've seen that speed.
Super fast. It's nice seeing it more like character by character across that old screen.
Somebody asked, what is Zorks? From the people that didn't use BBSs in the day, you could describe that maybe.
It's a text-based adventure game.
Yeah.
It was pretty popular in like late 80s, maybe? Probably late 80s. Yeah. So you can play the game interactively, but it's just text-based. So you can connect it in and the game runs on the Raspberry Pi. It sends the character output back across packet to your station, and then you interact with the game and you interact with it over the radio.
I do remember what the lights went out, you would usually die.
Yes. Eaten by a grue.
Grue always would kill you if the lights were out, yes.
That's right.
Nice to see the little blue box back in operation again after so many decades.
The PK232?
Yep.
Yeah. I picked that up at one of our White Elephant sales, I think for $30 maybe. I think I paid for it.
Mm-hmm.
Yeah, it's working well. It works good.
Used it a lot back in the 70s, 80s. Yeah.
Right. Yeah, it's working well.
So do you keep your bulletin board on the air 24/7 available or not?
No, I haven't. I probably could leave it on for a while if anyone wants to play with it. I could leave it on for a few days, but I haven't really got it set up to leave on permanently. But yeah, it's just nice to play around with. If anyone's interested, I'll leave it on for a few days. Just to let me know.
I think the show today is a very, very good evidence that amateur radio is definitely dead. Nothing happening.
We're all busy. We're busy doing things, making our projects.
There still is a 2-meter VHF packet net that gets on Sunday evenings.
Sure.
You've probably checked into that, Kevin. I think it's on 145.05, right? And that's I think 8 o'clock. I don't remember the exact time. But I fired up my PK232 about 4 or 5 years ago, and I used it for a while. And the problem was I couldn't keep it on all the time because I'm using my 2-meter station for whisper studies. And if you're doing one and it's not compatible with having the other on at the same time, you can't use, like, if you had a bulletin board on 2 meters right now, you could not check into the 2-meter net and have at the same time because you'd be overloading your receiver.
Yeah, that's true. Yeah. If anyone's interested, if they want to try connecting into it, let me know and I'll leave it on for a couple of days. All right. Carol, did you get the scores collected?
Yeah, I did email those to both you and Phil, so you can all see. And did you want me to make the announcement then?
Sure. Okay. Yeah.
Okay. Well, we had 3 judges. We compiled all our scores together based on the criteria that Kevin mentioned at the beginning, and we have first place was Bob Mix, KF6ABC. Congratulations, Bob, for the Digituner V2.
Very good.
And second place, we have a tie between Ken and Dave Martin with both of their battery boxes. So it was pretty close, and everybody did a wonderful job, very high scores.
Thanks. Yeah, there were some great presentations there. Interesting to see the projects. So I have to admit, we didn't confirm what the prizes were going to be. So I think we need to follow up with you guys, like exactly what the prizes are going to be. I think in the past we did gift cards, but I think the board needs to get back together and confirm because we dropped it last week. We should have confirmed it last week, but we didn't.
Do we get to leave them in limbo for a month?
Yeah, before we can tell you what the prize is. Yeah, it'll be a surprise next month. We'll announce the prizes on the next meeting next month.
We added drama.
There you go. Something to look forward to for next month.
Now,
Can we do a prize
next
for
month
Hiroki for his battery technology?
Sorry.
Can we do a prize for Hiroki for his battery technology?
You know, he's awfully deserving. I think I mentioned that he's going to make a presentation for us.
that's good.
Tentatively, he thought February would work.
I vote we give him a box of mashed potatoes.
Don't forget the butter.
Potato buds.
Little sour cream. Yeah.
Sack of potatoes and a couple of lemons.
Next month, the Chris N6 ICW is going to give us an update on what's been going on with the repeater. And looking forward to that, Chris. There's a lot going on behind the scenes, so don't be sure not to miss that meeting. Also, we don't forget tomorrow night is going to be net night, starting at 8 o'clock. So please check into our net on 2 meters and then 10 meters and then the slow scan net. I want to thank Wilson, also N6 EMF, who is learning the ropes here on doing the live streaming on YouTube for our slow scan TV net. So that'll be very helpful for him to pick up on that when I'm not able to do it. The upcoming the Ham Fest up in Lincoln also is a big event coming up this month. So that starts at 7 a.m. and that's going to be at McBean Park on Saturday, the 18th of September. Looking forward to seeing you there, and also at the I'll be at the ARRL booth, and we'll also have a club table for the River City Arts. Thank you very much.
The club table for River City Arts, are we going to try and relieve Tom's garage of some of his ill-gotten booty?
I understand that's going to happen there because there's a bit of equipment there that was from the estate of Paul McIntyre, which will be available there.
Yeah, that makes a lot of sense. I'm pleased to hear it. You can park your car again, Tom.
There's more stuff in the way. It isn't all Paul stuff.
Oh.
All right, before we wrap up, any last minute thoughts or comments or anything else anyone wants to share?
I just want to mention that on the Slow Scan TV, 2 weeks ago, I was up aboard ship in Alaska and in the middle of the ocean. And I was able to, using the YouTube, to join and watch the thing. I would like to encourage anybody that if you haven't done so through the YouTube, it was fun doing that, mainly when you're doing from far away. It's just like doing an SSTV DX.
Yeah, I agree. I was busy doing something else one evening and I had a laptop with me. So I watched and chatted, I think, with Carol while someone was sending their image. So yeah, it's great, Carol, that you pull in people who are in the channel watching the live stream. It gets everyone to participate as well, even if they're on the stream. So it works really well. All right, well, congratulations to Bob and Ken and Dave, and we'll follow up next month with your prizes. Sorry for the delay, but we'll confirm for next month.
All right, it was fun, guys.
All right, it was a good one.
Yeah, guys.
Thanks, everyone. All right, thanks. All right, have a good one.
Very good. Thanks.
Bye.
All right, bye.
Y'all.